Okay, so in this example, we will take a look at the circuit and using Kirchhoff's current law, try to find a number of currents that are unknown. We're given a circuit with 6 elements. Some of these elements are in series, some of them are in parallel, uh, and some of these currents are given as known. Uh, just a quick recap for Kirchhoff's current law. Kirchhoff's current law indicates that for any given node, the amount of current coming into the node must equal the amount of current going out of the node. So here's a quick summary of what Kirchhoff's current law is saying. So we'll use Kirchhoff's current law to help us figure out certain currents in and out of a node. So let's start out with node A. So if you look at node A, the total current coming into the node, so there's arrow going into node A, is equal to 0 because you don't see any current arrows going into node A. However, we do see the current coming out of node A is I1, and there's also I2 that's coming out of node A. So in other words, node A, 0 current is coming in, but I1 and I2 are going out as combined. So we can write this using Kirchhoff's current law. Sum of current coming in is equal to 0, and the sum of current going out is equal to I1 and I2. In other words, I2 is equal to negative I1, and I1 is given as 1 amp, so I2 is equal to negative 1 amps. So that's given as negative 1 amps. So we have negative 1 amps of current flowing through this element in this direction. What does that negative current mean? So it basically means that the current convention we chose is not the actual flow of the current. In fact, negative 1 amp means that the current is in fact flowing this way into node A, but we don't have to make that change. We just choose a direction and stay with it. The negative values will tell us that we had made the incorrect assumption. Okay, so now let's proceed with node B. In node B, the total current coming in is I2. So if you look at the direction of arrows coming into node B, I2 is going into node B, I3 is going out of node B, and I4 is going out of node B as well. So by Kirchhoff's current law at this node, I2 should be equal to I3 and I4. We know the value of I3. We know the value of I2. So I3 is 0.5 amps. So using Kirchhoff's current law, we can write down node B, I2 is equal to I3 and I4. And by placing in the values of I2 and I3, we get I4 as 1.5 amps. Now, by similar token, at node C, I4 is the current going into that node, and we see I5 and I6 are both leaving that node. So sum of current coming into that node is I4. Sum of current out of that node is I5 and I6, I5 plus I6. So by Kirchhoff's current law in node C, we get I4 equals I5 plus I6. We know the value of I4 from before is negative 1.5. Uh, I5 is not known, so that's not 15. That's I5. I5. And then I6 is given as 0.2 amps. In other words, I5 can be calculated as minus 1.7 amps. So we have this current that we just calculated as 1.7 amps, negative 1.7 amps.